Welcome viewers, in this video we'll see the introduction about the servo motors. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the topic servo motor. We know that this is used for the control purpose. Both AC and DC servo motors are available. Separate video available for DC servo motor and AC servo motor. This video will give the introduction about the servo motor. They are also called control motors and have the high torque capabilities. Normally it is used for controlling purpose. Unlike large industrial motors, they are not used for continuous energy conversion, but only for precise speed and precise position control at a high torque. Like a normal motor is not continuously rotating. It is used for speed and position control with a high torque. At the high torque, speed and position control, for that purpose these motors are used. Of course, their basic principle of operation is same as that of other electromagnetic motors. However, their construction, design and mode of operation are different. Their power ratings vary from a fraction of watts up to few hundred watts. Due to their low inertia, they have high speed of response. That is why they are smaller in diameter but longer in length. Right? So the low inertia, so high speed response. Small changes will responded in the speed. So that smaller size diameter but length is there. They generally operate at a very low speed or sometimes zero speed. Zero speed also possible. They find wide application in radar, tracking and guidance system, process controller, computer and machine tools. Wherever we need a precision control, there we are using this radars, tracking and guidance. In that, this rotation is not important, just moving the position with high torque, so that in tracking and guidance also we are using this servo motor, process controller, computer and machine tools. Both AC and DC servo motors are available at present. Two-phase as well as three-phase motors are available. Now we will see some application capabilities. What are the capabilities of the servo motor differ from others? Servo motor differ in applications capabilities from large industrial motor in the following respect. First one, they produce high torque at all speed including zero speed. Always the torque is very high, even the zero speed. They are capable of holding a static position, that is no motion, static position. So that is used in the radar and tracking guidance system. It will hold a static position. They do not overheat at standstill or lower speed. Right? There is no problem of any overheating, even at the lower speed or standstill. Due to low inertia, they are able to reverse the direction quickly. Low inertia is there, so reversing of the direction is made easy. Quickly they will reverse the direction. They are not accelerate and deaccelerate. They are able to accelerate, deaccelerate quickly. Acceleration, deceleration can be done quickly. They are able to return to a given position time after time without any drift. Without any drift, they will return to the original position. With drift means there is no time delay or position changes. There is no change in position. Automatically, it will get back to the original position without any drift. This motor looks like a usual electric motor. Only the diameter is lesser and length will be more. Their main difference from the industrial motor is that more electric wires come out of them for power as well as control. Normally in normal motors we have either 3 wires or 2 wires. For single phase 2 wire, 3 phase 3 wires. But here so many wires are available. This is for a control purpose. So controlling of this motor done by other electronic circuit. Right, so the control purpose so many wires will come out. The servo motor wires go to the controller and not to the electric line through the contactors. Only 2 line will go to the electric, other things will go to the controller. This controller will manage the DC servo motor or AC servo motor. It will give the instruction for rotation, speed rotation, everything is given by the controller. Usually a tachometer is mechanically connected to the motor shaft, tachometer, and sometime blower or fan may also be attached for the motor cooling at the lower speed. Right? Tachometer we can connect with the shaft. For cooling purpose, blower or fan is connected at the to cool the motor at the lower speed. So in this video we discuss the servo motor. What is meant by servo motor, how it is differ, what is the main application of the servo motor, and what are the capabilities for large industrial motors. The main thing is control purpose. For controlling purpose we are using this servo motor, not for rotation purpose, so that it is controlled by the controller, separate controller. Controller will give the instruction. For all the operation the controller will give the instruction. AC and DC servo motor separate video available, link is given in the description box. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening. All the best for your examination. Welcome viewers. In this video we'll see the details about DC servo motor. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the topic, DC servo motor. So this servo motor is a position control motor, not a continuously rotating motor like conventional motors. Conventional motors continuously rotating. This is not a continuously rotating motor. It is a position control motor. That is used for the radar system, position control system, and other mechanism where we need a control. In that we are using this servo motor. So it is controlled by the separate controller. The entire operation of this servo motor is controlled by controller. This controller gives the instruction based on signal, control signal, based on that it will operate. So we have DC servo motor and AC servo motor. So the AC servo motor separate video available. Similarly, the servo motor introduction, details about servo motor also separate video available. The link is given in the description box. Now we'll go to the topic. So this is the position control motor, not a continuously rotating motor. Now we'll see the construction. These motors are either separately excited DC motor or permanent magnet DC motor. So it is like a DC motor, in that separately excited. So DC motor we know that armature and field is there. The field is separately excited, then armature in that supply is given. The schematic diagram of a separately excited DC motor along with its armature and field MMF and speed torque characteristics are shown below. Now we'll see the detail. So the diagram is given. So this is armature, rotating part. So field, this is separately available. Excitation given separately. DC supply is given. So the LA is the armature inductance. RA is armature resistance. XA is armature impedance. LA plus RA will give XA. So it is excited separately. The important thing is this armature MMF and field MMF are quadrature. That is 90 degree. The phase shift between this armature and field winding is 90 degree. We already discussed this is not a continuously rotating machine. It is a position control. Wherever we need it will rotate either forward or reverse direction and it will make our required position. So any small change in armature that will reflect in the speed of the motor. So both are quadrature, means both are opposite, completely opposite. So there is a small change in variation in any MMF that will reflected in the position of the motor. So accordingly it will rotate. So it is not because of this quadrature not rotating continuously. Small changes will happen when there is a small change in armature MMF. So that is used for the position control of the wherever we need position control, in that we are using this motor, right? So the another thing, speed torque characteristics. Another important thing is the speed torque characteristics. Now we'll see the diagram. So the speed torque characteristics is given, x-axis speed, y-axis torque. So it is a inversely proportional, negative slope, both are inversely proportional. These are all the different voltages, V1, V2, V3. V1 is greater than V2, then V3. So when the voltage increases, the level also increases, but it is going in a negative slope. That is also an added advantage. So any small, if the speed increases, the torque will decrease. That is the another important characteristics of a servo motor. Now we'll see the description. The speed of a DC servo motor is normally controlled by varying armature voltage. This armature voltage. So we can control the speed by armature voltage. Then what is the advantage of this negative slope? Their armature is deliberately designed to have large resistance. Armature is, we already discussed, RA, LA. This LA, RA is very large. So the torque speed characteristics are linear. So linear. So it's going in a linear manner, not a parabolic. And have a large negative slope. So we have large negative slope and also linearly varying. So any small change in voltage will change in the speed and torque in a linear manner, not in a parabolic manner. Now we'll see what is the advantage of this, the negative slope. The negative slope serves the purpose of providing viscous damping for the servo drive system. Viscous damping. Damping, we know that it is used for damping purpose. Damping means it will provide it will provide the control force. One of the control force is the viscous damping. So this, due to negative sloping, we have more viscous damping is available, that will be used for control purpose. So we'll see this quadrature, armature MMF, field MMF, with that we'll see the detail as shown in the diagram. The armature MMF and excitation field MMF are in quadrature. Quadrature means 90 degree. This fact provides a fast torque response because torque and flux become decoupled. So there is a fast response. Any small changes will be reflected immediately. Accordingly, a step change in armature voltage or current produces a quick change in the position or speed of the rotor. Right? So this quadrature, what is the important thing? A step change in armature voltage or current will produce the quick change. There is no delay. Fast torque is there. Quick change in the position or speed of the motor. That's why it is used in the position control. So in this video we discuss DC servo motor. What is the construction and what is the important thing? Quadrature, armature MMF, field MMF or quadrature. Then speed torque characteristics, linear and also negative slope. So that provide more viscous damping. So because of this quadrature, any small change in armature current or voltage immediately responded by the motor in terms of position or speed of the motor. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening. All the best for your examination. Welcome viewers. In this video we'll see the details about AC servo motor. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the topic, AC servo motor. We know that servo motor is a position control motor. It's not a continuously rotating motor. Mainly used for position control. That is for used in the radar, tracking system, guidance system, process controller, computer, machine tools. Wherever we need a position, just we need to change the position In that we are using the servo motors, not for continuous rotation motor. This motor is controlled by a separate controller. This controller will give the control signal to operate this motor. It's called a servo motor. We have DC servo motor is also available, and that separate video available for DC servo motor. Link is given in the description box. And also introduction about the servo motor, also separate video available. So in this video we will see the AC servo motor. So the construction wise, presently most of the AC servo motors are of the two-phase scroll gauge induction type and used for low power applications. Two phase will be there. Normally it has one is the fixed phase, another one is a control phase. What we need is control. So one phase will be fixed, another one control. That we can change the voltage in the next phase. This is scroll gauge induction type. That is for low power application. However, recently three-phase induction motor have been modified for high power servo system, which had so far been using high power DC servo motors. Right? Normally we are using for high power, we are using DC servo motor, that can be now replaced by three-phase induction motors. Now we'll see this one by one. First we'll see the two-phase AC servo motor. So this is a two-phase AC servo motor. Gauge rotor is available. The bars are fixed. The coils are fixed here. There are two phases. One is fixed phase. Vm is the applied voltage. Angle is 0. Another one is control phase. Applied voltage is Va with 90 degree plus or minus 90 degree. So there is a phase difference between fixed phase and control phase is 90 degree. So because of 90 degree, if any small change in current or voltage in this control phase, that will be reflected in the speed or position of the rotor. So it will not allow for any small change, and also it is not rotating continuously. Any small changes that will be reflected as either speed or position control. That is the main advantage of this servo motor. The important condition is two phases are there. That the phase difference between these two phases, fixed phase and control phase, should be 90 degree. Then only we can use for position control. I will see that such motor normally runs on a frequency of 60 Hz or 400 Hz. The stator has two distributed windings which are displaced from each other by 90 degree. That is the important condition. 90 degree means there is no rotation. It is one is opposing by another one. So any changes in that will reflected as a speed control or position control. So that only our requirement. Our requirement is not continuous rotation. The main winding, also called reference or fixed winding, is supplied from a constant voltage source Vm with an angle of 0 degree. Now we will see the other winding. The other winding, also called a control phase, is supplied with a variable voltage of the same frequency as the reference phase, but is displaced by 90 degree electrical. So there is a phase difference of 90 degree between control phase and fixed phase, so that we are getting a position or speed control for any small change in voltage or current. Then this is the speed torque characteristics is available. The speed is there, negative speed also available, torque is available in y-axis. So it is a negative slope, inversely proportional. High rotor resistance. When the rotor resistance increases, the value also keep on increases. This one refers high, this one refers low. Right? So negative slope is there. When the speed increases, torque will decreases. Now we'll see what are the advantages. The control phase voltage is controlled by an electronic controller. I already told you, is controlled by a controller. From controller we are getting the signal, control signal. From that only the servo motors are operated. Now we'll see the speed torque characteristics. The speed and torque of the rotor are controlled by phase difference between the main and control winding. Reversing the phase difference between this leading and lagging, reverse the motor direction. That is plus 90 degree, minus 90 degree is there. From that we can reverse the direction of the motor. Now we'll see the other detail. Then with the high resistance. Since the rotor bar have high resistance, the speed torque characteristics for various armature voltage are almost linear as well as the negative slope over a wide speed range, particularly near the zero speed. So it is linear. When the speed changes, torque also changes linearly. It is going in a linear manner and have negative slope. The motor operation can be controlled by varying the voltage of the main phase while keeping that of reference phase is constant. By keeping reference phase constant, by controlling the main phase, we can control the operation of this motor. I will go to the three-phase AC servo motor. This is about the two-phase. So the second type is a three-phase AC servo motor. A great deal of research has been to modify a three-phase squirrel gauge induction motor for use of high power servo system. Normally for high power we are using DC. So the research is going on to convert three-phase squirrel gauge induction motor into three-phase AC servo motor. Such a motor is highly non-linear coupled circuit device. Non-linear. Recently, I will see the remaining detail. Recently, this machine has been operated successfully as a linear decoupled machine like a DC machine by using a control method called vector control or field oriented control. So this is under research only, so the testing is going on. So normally it will go for non-linear coupled, but it is tested for linear coupled like a DC machine by using vector control or field orientation control. The vector control is a different advanced method. A separate video is available for the vector, what is meant by vector control. In this method, the current fed to the machine are controlled in such a way that its torque and flux become decoupled as in the DC machine. So based on the vector control, they are decoupling the torque and flux as usual in the DC machine. This result in a high speed and a high torque response. Right, so not implemented practically, it is under research, converting three-phase squirrel gauge induction motor into high power servo system by using the vector control. So in this video we discuss about the AC servo motor. We know that servo motor used for control purpose, position control, not for continuous rotation. DC servo motor available, AC servo motor available. So the separate video available for both. In this AC servo motor, two types, two phase and three phase. Three phase is under research. Two phase, we are using the 90-degree phase difference between the applied voltage of main winding and phase winding, so that we are able to get the position control. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening. All the best for your examination.